Dreaming big. I want to start off with what I'm going to talk about here is about to be able to dream big with on tiny devices. So our expectations with microcontrollers today are that they can do rather small things. And now I would like to change your mindset in this speech that now microcontrollers can do big things. And when I talk about big things, I'm talking about big things on edge AI, especially on edge AI. So, and just let me quickly give an introduction again about a fresh reminder about what's edge AI. So we have seen a movement from cloud-based AI going to on-device AI-centric AI, all the way to edge AI. My definition here of edge AI is where you do the AI processing at the right physical location where the data is generated. So as close as possible to the sensor. That sensor can be a microphone, can be a camera, or some vibration detecting device or something. Okay? And moving, what motivates moving from the cloud to the edge I mean, by now they're well known. It's ultra low latency because some applications they require direct interaction. There's no time to upload them to a cloud server and to get the results back. Privacy and security, of course, because a lot of data is transitioning in cloud-based systems. A lot of data is transitioning over the cloud to a server, and that is just not happening anymore because you can do it on the device itself. And with this, there's also an angle of sustainability. Because in terms of power consumption, we can avoid having high bandwidth and power-hungry links to the cloud. So we can do this all now on tiny devices. And this in terms of cost per inference is drastically reduced. Okay. So where do we see this trend happening? We see this trend happening in cities and buildings, for example, for traffic fluidification, for people counting in the city, and these kind of applications we see in the home. Devices in the home are becoming smarter without necessarily to have the connectivity to the cloud. The data is handled directly inside the home on the device. Industry 4.0, we see a lot more smart devices detecting anomalies in industrial production lines, for example. Healthcare, be it professional equipment or the personal healthcare equipment you have at home, they're going to be smarter, enabled by AI on the device. Personal electronics, it can be as we see a lot of traction for edge AI to do the AI processing on wearables like smart glasses, for example. They're going to be AI-enabled. Smart mobility, I already gave one example, is where you use traffic fluidification using cameras on the edge. Now, I just want to, so I'm working for STMicroelectronics, and this edge AI actually is not new to ST. It's a journey we started over 10 years ago. We started over 10 years ago with our first NPU, which dates back from 2015. Our first neural processing unit, which allows us to use AI processing on the edge. It started way back in 2015, so more than 15 years ago. And during this period, I mean, we've been investing a lot in, be it in hardware, be it in tools, on different aspects of doing edge AI. And the latest thing about edge AI is that in December, we recently introduced the STM32N6, which is our first STM32 microcontroller where we enabled AI. And this leveraging all the experience we gained over the last more than 10 years. We used this to define this new device, the STM32. So STM32 is a lineup of microcontrollers from ST. We have different portfolios for different applications, be it ultra low power, high performance, wireless. So we have a complete portfolio. And here we're talking about the STM32N6. It's our superhero MCU. So it's the highest performance one that we have. And the first one, especially the first one where we have this neural processing unit embedded. And we started a couple of years back developing this product with the ambition, again, I want to allude to the title, what if we can, on a tiny microcontroller, start doing big things? And with big things, I mean things that in the past have been running on the microprocessors. Okay? So our goal with this product was to combine the best of both worlds. So give the user experience that so far has been seen on microprocessors and bring that to the microcontroller world. Okay? So, and there we exploit the advantages of the microcontroller world, being having smaller physical footprint, especially important in wearables, having a low power, again, wearables. Everybody's looking to optimize power today in their solutions. Lower overall cost because we drastically reduced the BOM cost. And one of the aspects also for certain devices, like consumer devices, you turn it on, you want it immediately to be turned on. And this comes with the advantages with MCUs that are most of the time running real-time operating systems, while this were running more Linux-based devices. Okay, so I'm talking here about bringing MPU-type user experience on the microcontroller. So let me explain to you what I mean with MPU-type experience. So these examples here, I don't want you to think that we invented a new thing doing people detection on microcontrollers here. That's not the point here. You have all seen these devices, but today we're running them on a microcontroller. Everybody has seen it. I mean, you don't have to walk very far here in the Embedded World Conference to find these kind of demos. But they're not running on a microcontroller. Most of the time, they have a fan or something, or they have quite a big PCB. Here, they're running on a tiny microcontroller. These kind of things, very snappy, and actually, sorry. And actually, you can actually interact with those on our booth. STMicroelectronics. You see, I mean, these are not accelerated videos. They're as snappy as you can see here on the video. So let me go into a bit more detail now about this product, the STM32N6. So what's the key? How can we bring such user experience in terms of performance for AI, edge AI? How can we? I mean, what's the secret? How do we do this? Well, first of all, as I said, we have this neural processing unit, which is 600 GOPS of processing power. So 600 GOPS. Today, our highest performance microcontroller, non-accelerated, we expect to do about 1 giga operations per second for AI processing. So here we're talking about doing 600 times more compute power for AI processing. So a real step up here. We are using the Cortex M55, so Cortex M55 with its SIMD instruction set for DSP processing, complementing our neural processing unit, of course, for pre-processing, post-processing of data for DSP. We have a large amount of embedded RAM, 4 to 2 megabytes of embedded RAM. So you can run your AI models. The AI models I just showed you, they run all out of embedded memory. So there's no need to hook up external memory to run these kind of applications. Okay, so also there, more efficient BOM cost, overall lower power. Okay, so 4 to 2 megabytes is a very contributing factor to enable such user experience. And since we have this performance available, we see a lot of traction in computer vision type applications. And that's why we thought it was very important to also support a good camera ecosystem. So that's why we needed the MIPI CSI2 interface and an image signal processor. Okay, an image signal processor, also here, we introduce something new to the microcontroller world. Most of the time, they've seen the microprocessor world. They're very common there. Microcontrollers with the ISPs are more rare. On top of that, we have multimedia capabilities. We have graphics, 2.5D graphics for human-machine kind of interfaces. We have H.264 encoding for those customers who do want to do AI on the edge, but also want to stream maybe the video, store it locally on an SD card, or send it via Wi-Fi link over the web or to the cloud. That's also possible because we have the encoding technology on board in the STM32N6. And then, as always, with ST, we have a huge investment in security to protect our customers, the source code, their weights, their AI networks from attacks. So a little bit on the neural art. So the neural art is the brand name we have for this neural processing unit. It's an internally developed IP. So leveraging this more than 10 years of experience in developing hardware prototypes, developing the tools. So this is all based on that experience. It's a sizable, it's a configurable IP that we have. So you will see this being used more in the future in ST products. And I talked about this huge step up of performance, 600 times of AI performance compared to our microcontrollers. So what can we use this AI performance for? So what can we do with all that thing? Well, we can do, instead of monomodality workloads, we can go to and run multi-AI networks in parallel because we have the compute power to do this, and certain applications require for that. For example, the hand gesture one that I showed, the pose hand landmark detection, that is actually running two AI networks. One that detects the palm and one that detects all the key points of the hand. Okay, that's one good example. Also, we can detect faster objects. Use this to increase the frame rate. So here, there are all the arguments of why we are looking to beef up the performance. Now, if you take away the NPU aspect from this microcontroller, we still have a very high performance, highly capable microcontroller. We're talking about a Cortex M55 running at 800 megahertz. We're talking about accelerated graphics. We're talking about H.264 encoding, camera pipeline. So all this is also available in another product line, which is the general purpose line. So we have two lines up for this product. One is the AI line, and one is the general purpose line. Okay? And I know we have probably many engineers in the audience, and now I'm going to show the slide that everybody is waiting for, which is the block diagram. Everybody wants to see the block diagram, because I could have started with this, and just in 5 minutes my presentation would have been done. Most of the people, they know what this means. So you can see just from the mirror all the blocks that we have on this block diagram. That it's really a high performance, it's a colleague of mine yesterday called it the monster MCU. So again, Cortex M55, the neural art. We have the embedded RAM, the 42 meg of embedded RAM. We have Hexa SPI, so 16-bit dual data rate interfaces if you would need external RAM. We have Octo SPI, which you can use to hook up external flash to store your weights of your models. We have the camera pipeline. We have the graphics with the H.264, the different JPEG encoders that we have. So very well. And then, of course, it's an STM32, so it carries the DNA of the STM32. Which means that we have a very rich peripheral sets for many type of applications. And talking about many type of applications, that's why to cover all these different type of applications that we see our customers using this device in, we have a complete lineup of 6 packages. Okay, 6 packages, which is our smallest package. We see 6 by 6 millimeter in a 0.4 pitch technology. So there we see a lot of traction in wearables, of course, all the way going up to 0.5 pitch, 10 by 10, 8 by 8 millimeter, all the way up to the 14 by 14. So trading off the number of I/Os, trading off the technology you can use for your PCBs. So large, there's something for everyone, basically. Okay. Now, what are the markets that we see this product being used in? It's like an STM32. It's very diversified. We see this in toys like drones or accompanying robots. We see this in the smart industry for anomaly detection. I mean, I don't want to go over all of them. I just want to show here that it's a very broad range of products that we see being built today by our customers. And you can actually find the product from our customers, which are AR glasses developed with the STM32N6 on our booth. Now, all this is good. We've been talking a lot about the hardware features. So what about the development ecosystem, which is as important, if not more important, than the hardware? So we have a whole lineup of boards, starting with the Nucleo board, which also has, again, a camera interface. So you can do computer vision type of applications with the Nucleo board. We have our Discovery Kit, which out of the box will be delivered with a camera. So you can, out of the box, start developing your computer vision type of applications. We have different camera boards available from our ST cameras. We have very range of small to larger global shutter cameras, which we will talk about later also on this booth. So that's from the hardware side in terms of PCB. We also have an ecosystem of third-party companies that have already disclosed some boards on the market, so you don't have to stick to ST boards. There are boards from Ciena Systems in the US that are doing, so there's a whole ecosystem that's going to be available in the near future. So in terms of tools, I mean, this is an STM32. So all the tools, for those who are familiar with STM32s, this shows that it's an STM32. It has the DNA of all the other STM32s. So large amount of tools, the STM32 CubeMX to configure your I/O, your clock tree. So that exists supported by the STM, by the N6, CubeIDE for your software development, supported also by the, also supports STM32N6. On top of that, we have different RTOS support. So we have FreeRTOS, ThreadX, and Zephyr support for the STM32N6. So now the next thing is, so what about the AI part? How do I get started with AI? So there also, we have a complete tools. We have the Edge AI developer cloud. That means you can upload your models to our cloud, and it'll give you feedback on what the performance is. It'll run on our devices, on the STM32N6 in our cloud, just to get you feedback. So you don't have to install the tools. You upload your model, and you get the profiling information back. We have a model zoo. A model zoo means that these are on-the-shelf AI networks that you can use. You can retrain them with a basic data set. You can retrain them with. You can freely use them. They're free of charge. You can retrain them with your own data set. And then we have the CubeAI toolset. So CubeAI is our toolset that allows you to any of your favorite frameworks for your AI development. You can go through ONNX or port it directly, feed it directly to CubeAI, and you basically generate code that does an inference on of your AI network directly using the NPU. So it's aware, it does what a compiler does. So it does a lot of optimization, graph optimizations on your AI network. It's fully aware of the microarchitecture of the chip. So this really hides you from all the tiny details, the gory details that might be in the microarchitecture. So this makes deploying. We wanted to make the deployment of AI models as easy as possible. Now, to get you started as soon as possible, we have some examples that you can start with. So people detection that was shown earlier, we deliver that in source code. So this is one of the simplest examples to get started. It shows you how to set up the camera pipeline, do an inference of the AI network, so a good starting point. If you want to do something more difficult, you can start with this, the multi-pose estimation. Here we show you how to run two networks in parallel. I just mentioned there are two networks running there. And here, if you want to do in parallel, do AI inference and do H.264 encoding, this example will show that. Here you can hook up the board to your PC. It'll show up as a webcam. So this is also something that we deliver in source code. And also, as I told you, Edge AI comes with the advantage of low power consumption. So also many questions about power consumption. So here we set up how you can do your own custom power. So there's really no excuse not to get started once you get out of here. So thank you very much for your attention, and I can take questions. Any questions? Go ahead, please.
Hello. I was quite interested in what you said about the power consumption, and if you have any, let's say, data that you have analyzed, considering embedded is a solution, working like full power. Yes. How much what would you need actually to dissipate that?
Yes, of course. Okay, so there's a whole range. It all depends on what you want to do. But what I can say is, I have many customers, and when they ask the question, they expected how many watts it would come, and we're talking about several tens to a couple of hundred milliwatts for these kind of applications. You see, you can imagine in AR glasses, going beyond that is totally not acceptable. Okay. Thank you very much.